Everyone. Today I'm going to introduce you to the Google spreadsheet implementation of a LiPid file, sort of just how it's structured, how to navigate around it, and then how to start editing and adding data to that. So if you first open a file, it will look something like this. There'll be multiple tabs at the bottom. The first one here is metadata, and then there can be any number of paleo data tabs, worksheets, and cron data worksheets. So if you're working in a situation where a lot of the metadata has already been populated in these fields, like in the ISO 2K project, it would look something like this, where there's lots of metadata already filled in. If you're starting with a blank spreadsheet, it'll just be a bunch of blank fields that are available for you to fill in. Either way, the structure design and the way you go about populating this is the same either way. So a bit more just about the structure. So on this metadata tab, has just a whole bunch of metadata on it of different kinds. There's essentially three sections of metadata. There's this top section which has metadata about the dataset as a whole. This middle section which has metadata about each of the columns that are paleo data, and then the third section which is metadata about each of the columns that are chronological data. So let's start at the top. This first section here in the dataset wide metadata is called base metadata here. It might other places be called root metadata. This is metadata that applies to the dataset as a whole. These are things like the archive type, the other pieces of information that you're probably not going to have to mess with too much. The second piece here is publication metadata. In this case, a DOI was provided, and so LiPid was able to populate the rest of these fields based on the DOI. So this should hopefully be pretty complete. The third section here is geographic metadata. In this case, it's just the latitude, longitude, and site name. And then the fourth category of this sort of dataset-wide metadata is called funding metadata, and it gives some metadata about how this research was funded. The second set here is the paleo data column metadata. So here we're looking at on row 16, there's a bunch of variable names here, most of which start with paleo data here, but actually as you'll see as we scroll to the right, there's more things over to the right. And then multiple rows, and there's one row that corresponds to each column. So for example, there's in this data set, we know about, so far there's metadata entered for 3 columns, depth, year, and delta 18O. And each of these columns corresponds to a row, and there can be lots of different metadata or not for each of these columns. Some of the key things to notice here, the first row here is called TSID. This is a pretty important field that, for the most part, you don't want to mess with. So this is how LiPid links the metadata from this spreadsheet to the actual time series, the actual data set on the additional sheet. So you'll see those two fields need to match, and I'll talk about in a later video if you need to add an additional column here, how to do so. The next one here is paleo data variable name. It's just the name of the variable. This is one that has to be populated. You can add a description of that, the units of that. There's a variable here called paleo data measurement material, which is important for some projects, especially the ISO 2K project. And it goes on. Another really important field here is this one here. It's called paleo data table name. So in this case, all 3 columns, they're in the same table. So the name of that table is the same in all cases. And this S1 matches this name of this worksheet down here after the paleo data dash. This is very important. This is another way that we're able to link the metadata and the data together. So if the data is already filled in here, the key thing is to look and see if there's anything missing. See if during the processing any of some special characters, like for this example, got removed or deleted. In this case, it looks like a plus or minus per mil and a per mil got messed up. So feel free to replace those. Just could say plus, minus, per mil. I didn't like that because I think it's a function, but it's not a function. One more time. There we go. Okay, and then so everything that's in the under the payload data that applies, it's going to be column Y. There's also some special metadata fields here. There's a whole bunch of things for isotope interpretation. There can also be climate interpretation variables here that can be populated, calibration variables here, and so on. So hopefully most of these are already populated if you're in the ISO2K project. If they're not, then some of the key things you're probably going to want to fill out are things like climate interpretation, variable, climate interpretation, direction, things that you might want to search on later to be able to work with the data. And then the third section here, the cron data column metadata, is exactly the same as the payload data column, in that this is the metadata that describes each of the columns that are in the subsequent data tabs, data sheets. And again, it has a TSID, it's going to have variable name and units and description, and a table name, and not much else in this case. So if you're here to mostly just check the metadata, you've done that. Say you want to add a field, you know the elevation perhaps. So we might say so geographic metadata. This is going to look like geo elevation. You're going to note that everything's going to have a prefix and an underscore, except for things in the very base metadata. So anything that has prefix and underscore, like geo, it'll go into the geo section. It's called elevation. For the site, we'll say it's like 60 meters above sea level. Put that right there. So that's done. And now we have to get to the real work, which is just copying and pasting in the actual data sets corresponding to these columns here. So we do that with the paleo data first. So if this is populated from metadata and there's no actual data behind it, this is what it'll look like. There'll be a column for each of the sheets that there's a row for in the paleo data, but all the actual entries we filled in with nans. The first two rows, the first row will just be a human readable name of that variable to make it easier. That can be this. You can edit this if you want to. This is just for your reference. It doesn't actually go into the database at all. The second row is that really important TSID row. So each of these columns need to match these all the TSIDs in these rows, and that's how that information gets translated. So so I have an Excel spreadsheet open over here. I'm just going to copy and paste some of this data in. So this is a good example. So in the spreadsheet, it's organized a little bit differently. It goes in the spreadsheet. It says depth. You can see it. And the spreadsheet is organized by depth, year, delta 18O. So that's okay. I can still just copy and paste this directly in. Well, I guess one way to do it is we could leave everything the same and say copy depth and put depth in right here, and then copy year, put year right here, and copy delta 18O, put that in right here, and you'd be all set. You'd be done. It will automatically put the right number of rows there. We're all set. So you had a huge table and you didn't want to go column by column. You think it'd be easier just to copy in the whole table and then move around the column, the names of the columns. You can go ahead and do that too. So let's then copy paste the whole thing. So now it goes depth, year, and delta 18O. So we need to switch these two headers over here, both the name and especially the TSID, because otherwise it would be confused. So I'm just going to make another row here just for convenience. Copy and paste that out of here. Copy and paste this over here. So now it looks right. And so now these columns are in a different order than the rows on the metadata sheet. So it says it goes depth, year, delta 18O. This goes delta 18O, year, depth, and that's fine. That doesn't matter. As long as the TSIDs match, you're all set. Okay, so we've all done with the metadata there. All done with the paleo data. So let's move on to the cron data. And again, it's the same thing. These cron tables have a lot of variables, and most of the chronologies aren't going to have as many. So we don't have to feel like we have to populate all of these, but I'm going to do the same thing. I'm going to grab an Excel spreadsheet and just start copying in some of these rows. So here's what this looks like. So we have a, let's see, depth. Depth is right here. And radiocarbon age. Right here. And radiocarbon uncertainty is right there. We have some, we don't have fraction modern, so we can go ahead and delete those. We don't have delta 50C. I don't think we have thickness. We do have lab ID. Delete columns. So it's fine to delete columns that you're not using. In fact, it's better than to leave them full of nans. Speaking of which, if you do want to indicate that there's data that are missing, please do use this in nan convention. Okay. We have some information about the material that was dated. So this would go under here, right here, material dated. We don't have any lead-210 information here. Our reservoir ages, so we're able to delete a whole bunch of columns there too. And we have this last field, which is called use an age model. This is if the author has rejected any ages, which in this case is true. Let me put this right here. Okay, so copy and paste this in with some trues and falses. And I don't know if I accidentally deleted it, or if, let's see if I did. Was there a notes section? There's not a notes section. So we'd like to add some notes in here. So we can go ahead and add an additional column. So we're going to the right. I'll call this notes. We'll make up a new TSID. Doesn't matter what it is as long as it's not the same as any of the other ones. And we can put this in right here too. Okay, so we cut this down to only 7 columns, but we still have everything we need, or everything that was reported for the chronology. And now we can come back and make the same changes in terms of getting rid of some of the columns that are extra in the metadata. So we'll pop back over here's the metadata, and we got rid of some of these. So we got rid of fraction modern all the way down here through thickness. So we delete those rows. We got rid of the all the lead-210 stuff. All of these. Delete rows. And we'd like one more row here at the bottom. And we have made up a new TSID, which is fine. It's fine to make up new ones, just as long as they don't match anything else in this spreadsheet. This one is called notes, and it doesn't have any. It's self-explanatory. It's very important to tell it which table it's in, otherwise it won't know which table it's in. These 2 things we can leave blank. So this is all set. So we've now finished updating this file. It looks pretty good. We have lots of metadata. We've actually added a variable to the cron data. We deleted a lot of the variables that we didn't need. We've copied and pasted all the data, and so now this is it. So everything's saved automatically. There's a really nice versioning history in here. You can see all the changes we've made. If you make a mistake, you can always go back and change it there. And so once you've done this, you're set, and you can close it. So, okay, keep an eye out. I think that there will be some more videos that show maybe just some subsets of this, or some specific instructions about how to, say, create an additional table. But this is the basics, and you're more or less set up to create new lipid files or edit existing lipid files through Google Spreadsheets. So, thanks everyone.